Hello friends, good morning to you all. My name is Radhey Bairagi and today I'm again here for you people along with me as I am studying this book three times. Okay, and this is my target. This I will complete this book fifth to six times. Okay, as you all know that RSMSSB JE Civil Engineering the exams are cancelled out and the RSMSSB will again think to conduct the same exam. Okay, there will be more vacancies possible. So let us see. Yesterday we were studying what the SRB, DRB, FV, and BIM of structural analysis. You know all about these things, so I no need to expand that. Let us play with the question number 54. The maximum strain in steel at failure in limit state method of design is, just remember, Fy upon 1.15 ES plus 0.002. ES is what? Modulus of elasticity of steel. Fi is stress in steel. So correct answer is A. Just remember this. This is very important question. They ask in every exams, not from Rajasthan, from other states also. You can see also in the concrete it is strain 0.00 point 0035. So this you can also remember. Let us move to the question number 55. The nominal cover for beam should not be less than what? For moderate exposure condition. For moderate exposure condition, nominal cover should not be less than 30 and for normal this is 15. For slab this is 25 for beam and 40 for column and 75 for footing. So this is general condition, but the moderate exposure condition should not be less than 30. For question number 56, the maximum spacing for shear reinforcement for beam should be less than equal to 300 This is very important question. Either they can put less than or they can keep equal to 300. Question number 57. In absence of detailed design, the percentage for steel in concrete may be taken approximately for beam is what? 1 to 2%. See, this is the practical questions without design. Okay. This we should remember, and this also remember to the contractor and so many people as a general knowledge. Okay. In absence of detailed design, the percentage of steel in concrete may be taken approximately for beam is what? 1 to 2%. This is very interesting question. Let us move to the question number 58. Effective span of a freely supported beam slab is list of A and B. Means distance between the center of the end support, clear distance between the support plus the effective depth of the beam. If the value will come and will less from above, A and B will take. So what is I mean to say that list of A and B we will take the effective span of a freely supported beam. Clear distance between support plus twice the effective depth of the beam. Now C is incorrect, not twice. So, clear distance between the support plus the effective depth of the beam. This we will take, or we will take distance between the center of the end supports. List of and we will take. Okay. And see question number 59. A doubly reinforced beam is used when the depth and width of beam have to be restricted. Then doubly reinforced beam is used. And in question number 60, a doubly reinforced beam is considered less economical than a singly reinforced beam because compression steel is under stressed. In this doubly reinforced section, compressive steel is also under stress. That's why it is less economical than singly reinforced beam. Let us move to the question number 61. The lever arm D minus x by 3. This is fundamental question. D is the distance between the top of the beam and the center of the steel bars, and x depth of neutral axis below from the top of the beam. Okay, so you can, this is the lever arm, and this is very interesting also and very helpful in many problems of civil engineering, steel design or structural analysis. Okay, so you must remember even lever arm, d minus x by 3. Okay. Question number 62. In uncracked reinforced concrete column, the actual bending compressive stress is obtained as M is the moment upon BZD square, where M, you know, bending moment, B is width of the column section, Z is the lever arm distance, A is the area of the transformed section, Z is the modulus of the transformed section modulus, we can say. P is equal to axial force, D is equal to distance of steel from the extreme fiber compression pipe. So generally you can take BZD square, Z is the lever arm, so M is equal to BZD square, sorry, M upon BZD square is the uncracked reinforced concrete column, the actual bending compression stresses. So they can give any value, they can give M value here, they can give B, they can give J, and they can go ask, they can give BD, J, and they can give M, and they ask, they can give bending compressive stress and the BZD square, and they can ask moment. So anything they can ask. So if the question will come from 62, you should not leave it, okay, blank. You should do it, you should solve it. Let us move to the question number 63. The deflection of any rectangular beam simply supported it was inversely proportional to the cube of its depth. The deflection of any rectangular beam simply supported is inversely proportional to the cube of its depth. Okay, C is the correct answer here. Question number 64. Tension failure occurs in a singly reinforced beam in tension failure occur in a singly reinforced beam in under reinforced section. In under reinforced section, steel fails first. Okay, that's why B is the correct answer. Question number 65. In a singly reinforced beam, the effective depth is measured from its compressive edge is to center of tensile reinforcement. This is very interesting question, and the basic question which we has to remember to apply for any solution, right? Question number 66. For continuous beam, the distance between 2 points of zero moments in the beam may be assumed as 0.7 times the effective span, right? So effective span to depth ratio is equal to 26, and you can say for continuous beam, the distance between 2 points of zero moments in the beam may be assumed as 0.7 times the effective span. Okay, and effective span to depth ratio will be 26 for continuous beam. Let us move to question number 67. The section in which concrete is not fully stressed to its permissible value, when stress in steel reaches its maximum value, is called under reinforced section. Okay, so this you should remember. Let us move to the question number 68. This is also very interesting. See, the effective depth of a singly reinforced rectangular beam is 400. Okay, the section is over reinforced. Okay, and the neutral axis is 180 mm below the top. So neutral axis is given, and if the maximum stress attained by concrete is 5 and the model ratio is 18, then the stress developed in the steel is what? So you can directly understand the concept here. CD is the total depth, you will subtract 180. So you can also calculate sigma st is equal to m sigma cb. See, this is also a kind of question we can solve, or maybe you can take this also. Maximum stress is 5 and x is the below, and the 220, the 400 is the depth, and 180 is the neutral axis. So remaining is 220, so 5 upon 180 upon x upon 220. You can also take this, the answer will come how much. This answer can become, okay, when you will solve, see the solve the question number this, x upon 220 and 5 upon 180, so 5 3 and 36 is here. X is equal to 220 upon 36, how much it will come? Okay, you can calculate here, 18 and 110, 18 upon 110. You can solve here 18 upon 110 upon 18. Again you get 9, and this is 55. So this is also you can calculate 6 times. So 6 is coming here. Okay, so x is coming 6, but x is coming 6, but here 6 is not given. Okay, model ratio is given. So you should do like this. See, m is equal to 813 sigma cbc, and sigma st is equal to. So let us see the solution of this question. I've solved this. This is very interesting question. But let us see the question here. 68. See the question number 68 here. This is the question number 68. 400 is the depth, and you can see this sigma c is 5 and is 18. Similarly, x1 to x will be 6.11. So you know, if x came 6.11, then sigma st is equal to sigma c. What is sigma c? Sigma c is 6.11. So if you will multiply by 18, 18 is the model ratio, the sigma t will come. So we have calculated here 6.66. Okay, this is 6.66. We have calculated approx here. This is okay. So if we will multiply this x is the stress in compression, stress in tension, I think. Yes. So if we will do this, so it will come sigma st can be stress in steel. The stress then started in the steel will you can calculate. Fine. See, sigma st should am sigma is the 6.1. Okay. So answer will be, you can calculate easily. Very nice question. I'm giving time for this particular question because there are so many questions came out from this one question. Okay, let us move to the question number. So you solve, the answer will come 110. Let us move to the question number 69. According to IS 456, simply supported beam of effective depth T, breadth B shall be so proportional that the clear distance between the lateral resistance does not exceed what? A. 60B or 250B square upon D, whichever is less. Please remember this, you have to remember 60B or 250B square upon D, whichever is less, where B is the breadth, D is the depth. Let us move to the question number 70. Which of the following is a primary cause of flexural collapse in overhand post? In overhand post, concrete fails first. So primary is what? Compression failure will happen in overhand post. See, in question number 71, in case of statically indeterminate beam, what is the limiting value of redistribution of moments percentage as per IS 45630 while using limit state? So see, what are the condition? Redistribution of moments, limiting value, and limit state method, and as per IS 456 and percentage, and the beam is statically indeterminate beam. So that will be 30. Okay. Let us move to the question number 72. A simply supported reinforced cement concrete beam shall be deemed to be a deep beam if its effective span. See, simply supported reinforced concrete cement concrete beam shall be deemed to be a deep beam if its effective span to depth ratio is less than 2. If effective span to depth ratio is less than 2, that will call what? That is called deemed to be a deep beam. Okay, see the correct answer. In question number 73, in a singly reinforced beam, if stress in concrete reaches its permissible value later than the steel reaches its permissible value. Getting it? The beam section said to be what? Got it? In a singly reinforced beam, if stress in concrete reaches its permissible value later than the steel reaches its permissible value. Means first steel reach the permissible value, then the concrete will reach. So that is under reinforced. In under reinforced, steel reach first and concrete reach later. Okay, so A is the correct answer. See, there are three questions related to this. I hope you have remembered that can be asked in the question in the examination. Question number 74. Beam curved in plane is designed for bending moment, shear and torsion. For 3. In limit state design, the limiting value of depth of neutral axis for FE415 is taken as D is the C. For mild state it is 0.53 I think D, and D is the effective depth, and for 415 it is 4.48 D, and for 500 it is 0.46 D. So here 0.53 D. Here for FE415 sorry 0.48 D. So C is the correct answer here. Question number 76. The deflection in a RCC beam is reduced by, as per IS 456 2000, controlling span upon depth ratio. The reflection in RCC beam is reduced by controlling span upon depth ratio, not moderating, not large aspect ratio, smaller modulation, no. Controlling span to depth ratio or deflection RCC beam is reduced. Okay. So this concept is given. Concrete if fails, then that is over enforced. If steel fails, then under enforced. Okay. Question number 77. Which material fails first in RCC over enforced section beam? That is in over, that is concrete, and under, that is steel. Okay. Those three questions you find here. Okay. Please remember, please note these down in your notebook. They can ask these questions. So span to depth ratio up to 10 meter is what? 20, and if it is more than 20 it will 20 into 10 by span, 20 into 10 by span, if it more than 10 meter. For 10 meter it is 20. So like this we will move in question number 78. In a cantilever beam, tensile or main reinforcement is provided what? At the top this is that is tensile, and at the bottom is the compression. On the top or upper face of the beam, tensile reinforcement. Okay, cantilever, in case of cantilever. In normal beam it is below. So if the correct answer is B. 79. Question number. In limit state method of design of RCC flexural members, the center of gravity of the compression forces acting on the section from the topmost fiber of concrete is at a distance of 0.42 of the depth of the neutral axis. C. Again read. In limit state method of design of RCC flexural members, the center of gravity of the compressive forces acting on the section from the topmost fiber of concrete is at a distance of 0.42 of the depth of the neutral axis. Of the depth of the neutral axis, please remember 0.42 of the depth of the neutral axis. So here the correct answer here. In question number 80, a simply supported beam has an effective span of 16 meters. Wow. What shall be the limiting ratio of span to effective depth as per IS 456? 12.5. You can calculate using C. A simply supported beam has an effective span of 16 meter. Okay. For 10 meter, what was that? Span to effective depth is 20. But if the length is more than 10 meter, as this is 16 meter. Okay, this is 16 meter. So what will happen? In this case, 20 into 10 by span. Whatever span they have provided, that will be the limiting ratio of span to effective depth ratio. Okay, so it will be 20 into 10 by 16. How much it will come? 200 by 16. So 5. You can divide by 2 with that 10. You can cut 10 by 2 as 5, and 16 by 2 is 8. So 100 upon 8 is the correct answer. So if 100 upon 8 is there, then you can calculate what will be the value of 100 upon 8. So easily can, for 10 it is 80, and again 82. So 12 upon 5 is the correct answer. You can directly divide. No issue with that. Question number 81. A doubly reinforced section is used when the members are subjected to alternate external loads and bending moments in the section reverses. Please remember, this is A is the correct answer. When the members are subjected to loading eccentric on either side of the axis, B also correct. When the members are subjected to accidental lateral forces, C also correct. So, because of all these three conditions, we has to design the doubly reinforced section or use. Question number 82. The maximum design stress and the area of the concrete block at ultimate limit state of fracture in a singly reinforced rectangular section is what? See, please remember both the formulas. Very interesting. They can ask anytime. Anytime, if you are a civil engineer, please remember these formulas. Maximum design stress is 0.447 FCK. FCK is the characteristic strength. And the area of the concrete stress block is what? 0.362 FCK BXU. FCK characteristic strength be breadth, XU is the neutral axis. So please remember 0.447 FCK is the maximum design stress. They can ask maximum design stress by giving the type of concrete. Okay, they can ask area of concrete stress block, that is 0.632 FCK BXU. Okay, you can remember by it is 236. Okay, and this is 4.7 FCK. So correct answer is A. Let us move to the question number 83. The concept of locating neutral axis as a centroidal axis in a reinforced concrete section under fracture is what? True for elastic material only. What is? The concept of locating neutral axis as a centroidal axis is true for elastic material only, not for WSM, LSM for both linear and non-linear. No, true for elastic material only. So correct answer is D. Question number 84. The stresses developed in concrete and steel in reinforced concrete beam of 250 mm width and 700 mm effective depth are 6.25 megapascal and 25 megapascal respectively. If M is 15, the depth of neutral axis is what? See, they are telling that depth of 700 mm depth and 6.25 megapascal is the what? Stresses developed the concrete. 6.75 and 700 is the depth, and that is XU is there, so 7 by XU. So if we will do 2 width is given, so 6 upon 6 upon XU, 6.25 upon XU is equal to sigma ST upon M upon 700 minus XU. So by putting the values, you will find the question number E, none of the above. It means what value will come in question number 84? In question number 84, the value will come. In question number 84, the value will come. See, this value will come 552.63 mm. So this is not given in the option. So the correct answer is none of the above. See, this relation, please remember, it can be asked in ACF exam, it can be asked in lectural civil engineering exam, it can be asked in JEE exams. So it can be asked in UPSC exams also if you are taking civil engineering subject. Okay, very interesting question. Let's move question 85. Diagonal tension in beam is what? Remains same. Diagonal tension in beam remains same. So see, diagonal tension in beam is what? Increases below the neutral axis and decreases above the neutral axis. Okay, sorry. In question number 85, the answer is C, not D, remains same. Diagonal tension in the beam will not remain same. See, diagonal tension increases below the neutral axis and decreases above the neutral axis. You know that below the neutral axis, why we provide steels? Because diagonal tension is there. Above, there is no diagonal tension or less diagonal tension, so we provide the concrete only. Question number 86. The final deflection due to all loads, including the effects of temperature, creep, shrinkage, and measure from as cast level of supports, roof, and all other horizontal members should not exceed vary with span by 350. final deflection due to all loads, including the effect of temperature, creep, shrinkage, and measured from the has cast level of supports, roof, and all the horizontal members should not exceed span by 350. Correct answer is C. Temperature. See, in what the question is asking, for all type of loads, that is span by 250. And for only for temperature creep and shrinkage, it is span by 350. So if they ask temperature creep and shrinkage, you should give span by 350, and in question number 86 the answer is span by 250. Okay. So question number 86 is here. And question number 87, the assumption that the plane section normal before bending remains normal after bending is used in both working states limit economy use cases. We use in both the cases. Okay. Let us move to question number 88. The following two statements are made with reference to a simply supported under reinforced RCC beam is what? Failure takes place by crushing of concrete in under reinforced section, not by crushing of concrete in under reinforced section, crushing of steel before the steel has yielded. Failure takes place by crushing of steel, not the concrete. So one is incorrect. Okay. The neutral axis moves up as the load is increased beyond yielding of steel. Yes, that's why in case second is the correct answer. So D, first is false and second is true. Okay. And in question number 89, which of the following deformations are important in case of deep beams when compared to flexural alone? Shear. Which of the following deformations are important in case of deep beams when compared to flexural? Shear only. Okay. So A is the correct answer. When the ends are confined by a compressive reaction MT upon V, see compressive reaction MT upon V can be increased by 30%. DDA JEE they asked in 2018, when the ends are confined by a compressive reaction, MT upon V can be increased by 30. Okay, so question number 90 is correct here. So in question number 91, for main reinforcement up to 12 mm for mild exposure, the nominal cover may be reduced to 15 mm for mild exposure. Nominal cover may be reduced to 15 mm for main reinforcement up to 12 mm. Okay, 15 mm. So B is the correct answer. 92. An 8 meter span beam is casted today. What will be the minimum duration days before the props to the beam can be removed? 21. The props of the beam can be removed 21 if 8 meter span is beam is casted today. Okay, for 8 meter props of beam is 21. Question number 93. A continuous beam will be classified as a D beam if the ratio of effective span to all depth is below 2.5. Continuous 2.5, simply supported. Okay, but the continuous it is 2.5, and for simply supported it is 2. Okay, so the continuous beam the classified D beam if the ratio of effective span to all depth is 2.5, and for simply supported it is 2. What is the objective of providing minimum tensile steel in reinforced concrete beam? Preventing brittle failure. Okay, we provide the steel. 95. The failure mechanism of balance section in WSM is what? Sudden failure. In the balance section of WSM, sudden failure is there. So B is the correct answer. Question number 96. The best section for reversal of stresses due to seismic load when the ductility criteria is not a concern. The best section for reversal of stresses due to seismic load when the ductility criteria is not a concern is what? Doubly reinforced. B is the correct answer here. And let us move to the question number 97. The L0 in the expression is L0 upon L0 upon B plus 4 plus B. So L0 is the effective span. Distance between the point of zero moments. A is the correct, not effective span, not clear span. This is A. L0 is the distance between the point of zero moments. A is the correct answer here. Question number 98. For solid slabs, value of K in K tau C for depth of slab greater than 300 mm is what? Is 1. For solid slabs, value of K in K tau C for depth of slab greater than 3 mm. Depth of slab is greater than 3 mm. So what will be the K value? 1. In T beam, when X is greater than DF and DF is greater than equal to 3 by 7 XU, then DF is replaced by YF. The value of YF will be what? The value of YF will be 0.15 XU plus 0.6 by DF. If DF is replaced by YF, then 0.15 XU plus, then YF is what? 0.15 XU plus 0.6 by DF. So is the correct answer. This you memorize. In question number 100, the effective span for continuous beam when the width of support is less than LC by 12. See, the effective span for continuous beam when the width of support is less than LC by 12. That is same in simply supported one. Okay. Greater than simply support, smaller than support? No. That is same in simply support. The effective span for continuous beam when the width of support is less than L by 12, that is same is simply supported. Question number 101. The slenderness limit of cantilever beam to ensure lateral stability is 25 p. For CC, concept is given here that slenderness limit of cantilever beam to ensure